In this video, we will learn the modelling objectives and principles adopted by RobMoSys. Both are the cornerstones of the RobMoSys approach. They enable us to develop predictable and cost-efficient software for robotics via models. A model is an abstract representation of how an actual system works. Models can have 5 objectives of levels of formality. They may aim to 1. Guide discussions to achieve harmonized interpretation of relevant entities and relations. 2. Explain explicitly the meaning and behavior of software in standard documents. 3. Support software development with tools and reference implementations that conform standard documentation. 4. Check automatically the meaning and behavior of software artifacts. Or 5. Enable robots to automatically check themselves or with minor human interaction at runtime via dialogues. RobMoSys addresses levels of model formality 2 and 3. The approach enables access to 2 integrated development environments: Smart MDSD and Papyrus for robotics. Both toolchains allow us to compose systems, develop software components, and generate code. Users gain the benefit of best practices in robotics components and system development with these tools because the tools comply with 2 modelling principles. The principle's separation of concerns and roles enables developers to focus on what they do best. RobMoSys disaggregates a robot system into different levels of abstraction and concerns. Each concern is a problem area viewed and usually solved independently from each other. Depending on the problem which needs to be solved, developers play any of the following 6 roles in the RobMoSys ecosystem. Safety engineers create constraints to make systems safe. System architects also create constraints, but this time to connect systems. Component suppliers, who can be function developers or service designers, use safety and system constraints to develop components that include libraries and service definitions. System builders integrate different components and task plots to create new systems. Behaviour developers create those task plots. This is, they model how a robotic system is orchestrated at runtime to provide a service as a whole system. And performance designers configure performance-related system properties. Separation of concerns and roles reduce software development complexity since the system is split up into parts, and each role develops solutions for different parts of the system. The second RobMoSys modelling principle is composability. This is a design principle that seeks components to interconnect. Interconnectivity demands to establish fixed and stable structures of software components. These structures increase the predictability of your robotic systems. They enable the exchange of software components from different systems while reducing software development costs. Composability adopts a freedom from choice perspective, meaning the RobMoSys approach guides developers in the selection of structures to satisfy their needs, ensuring system-level conformance. Composability is possible when models comply with metamodels. Thus, to build up a model, we should first specify the metamodel. Out of the metamodel, we generate a modelling language. We adjust the syntax or notation of the modelling language without affecting the structure defined by the metamodel. This syntax can be textual, graphical, tabular, or any combination thereof. Then, a developer creates a model that conforms with the modelling language. This model uses a concrete syntax and represents the in-memory model. The in-memory model uses an abstract syntax. The abstract syntax represents the system, conforms to the metamodel, and it is used to serialize the models and make them persistent. When we use modeling tools, the modeler interacts only with a specific syntax of the model and its modeling language. In summary, models represent how real systems operate. Since the goal of RobMoSys is to build better models with better tools, RobMoSys made available to the robotics community Papyrus for robotics and Smart MDSD toolchains. These toolchains follow the principles of separation of concerns and roles and composability. By following these modelling principles, RobMoSys helps to develop predictable and cost-efficient robotics software. To learn more about RobMoSys tools, visit the RobMoSys wiki at robmosys.eu. Also, check out our next videos to learn how RobMoSys helps you with the development workflow and RobMoSys views. Thanks for watching.